And all good online? All good online? Zoom? Okay, I think. Okay, I think we are good to go. Just double checking, is a Zoom stream okay? So you can hear my voice? Okay, good. So I have two mics and these are quite a bit limiting my movement. Okay, so welcome everybody to this workshop. And you can participate if you want to, you can sleep if you want to, it's okay. It's a good place to work also, like I think Roberto is working here. So let's move forward. So we're going to talk about tokens. And tokens, where are multiple display is always like now work? No. Okay, there we go. So a few words about me. So who am I? So I'm Nestori Syrima, also known as Dr. Azure AD, and I work for SecureWorks. Been there 2 years now in counter threat unit. And what I do there, I just research. So that's my job. So I research. I try to find vulnerabilities from Microsoft products, especially from cloud related. I report them to Microsoft and they fix it or not. And then also we have our own tool called Attendees, and they are using my research on that also, so that we can detect stuff and prevent stuff. But that's about that. What else? I'm Microsoft MVP in security. Also MBR, which stands for Microsoft Most Valuable Researcher. So this is my second year there. And every year in Black Hat US, they are going to publish the list of 100 researchers, and that's the list I'm on. So happy to be there. I don't know how it goes this year, but we'll see. I created a tool called A8 Internals. I think at least some of you know that. And those who are here, I have some stickers. So I have the basic ones, like these ones, and then shiny ones. So you can pick your own when you want to. And so the toolkit and we are going to use that today. So you don't have to use that if you don't want to, but it's easier for me to present stuff. And it's for hacking and administrating Azure AD and Microsoft 365. It's open source, so you can download it quite easily and install quite easily. And it has been listed by MITRE ATT&CK since last year, February. And is it any good? I don't know, but it has been used by a group called APT29, also known as Nobelium. So at least they found it useful. So learning goals for today. So I want that you understand what is the role of tokens when you are using cloud services, for instance. I want you to know that how Azure AD has implemented OAuth standard. It's a bit funny. And also that you will have skills to start analyzing tokens. So that's one of my hobbies. And I want you to learn that also. So yeah. And of course, at the end also that you would understand the basic attack scenarios you can do with the tokens. So content is there, and let's start by having a crash course on how cloud works. And by the way, you can tweet as much as you want to from this session. It's okay for me. And my tag is Dr. Azure AD. So how does cloud work? So there it is. That's how it works. So what do we have here? So first thing, what we have is clients. And by clients, I mean the piece of software. That could be Outlook, that could be Edge browser, or it could be a PowerShell client. So it could be anything. And then we have authentication part. So before you can do something with your client, you need to authenticate. And in this case, it's Azure AD, and it has a different protocols it is supporting. So it can be OpenID Connect, or OAuth 2, and usually it's OAuth 2. And now after you have authenticated, then you can use those services. And technically, even when you open a browser and go to Office, for instance, and open Outlook, what is happening back end is that you are using APIs actually. So the browser is a client that is using or calling those APIs. And that's how it works. So first you need to have the client, then you authenticate. And when you authenticate, you have something called access token. And then with that access token, you can go and consume the services. So that's pretty much a simple way, or simply put, how cloud works. And technical terms, so we have identity provider, in this case Azure AD, and then we have service provider. So these are the crucial components. So you need to have both. So also this identity provider, in this case Azure AD, it knows about the client and you as a user only what you tell to cloud. It has no other way to know anything about you. So you need to tell who you are. And what's the typical way to do that? Give username and password, right? And so on. And also the service provider. In this case, it could be Azure AD if you are calling Azure AD API, or it can be Azure, it can be Microsoft 365. So that service provider is trusting identity provider. And again, the service provider knows about you only what you tell it, same way as what you tell to cloud. And service provider also knows about you and the used client only what you tell, or identity provider tells actually. And how identity provider tells the service provider who you are, what device you are using, and even what authentication methods you use is in the form of access token. So that's how that information is delivered to service provider. Okay, what else? When you are authenticating against Azure AD, you need to give some proof of identity. And here are some options for that. So the username and password is a most typical one. And if you are calling, or if you are using like OAuth terminology, it's called ROPC, or Resource Order Password Credentials. You can use authenticator software. You can use FIDO2 keys. So there are a lot of options that you can actually achieve things. And in Azure AD, we have a lot of things stored there, but at least there's 3 identities. So you have the user identity. So there's a user object. We also have like device identities. So if you have devices joined, and then we have the application or client, it's the same thing, different name. So we have also identities for those. But we're going to see these in action. So now let's start our first kind of exercise. So how many of you have installed Fiddler or Burp Suite in your computers? So quite many, yes. So you can use that, but if you don't, you can use the hacking button F12. So I'm going to show what how we can start this. So you can do this also with your Fiddler. And by the way, does everybody have the credentials provided? This small one. Okay, so you can use that, or you can use your own credentials. So it's up to you. But if you don't want to, because this is a kind of a hacking session, you might not want to use your own. So yeah. Okay, so I don't know, can I talk and type at the same time? But let's try. So I hit F12 and it opens up the developers tools right here. And now I'm going to browse to Office. No. What's the Wi-Fi password? Wi-Fi password is NorthSec 2023, right? Okay, so now I signed in, and the question was that can you see any tokens? And I have a hint for you. So for instance, if you are using this F12 or develop tools and staying with Fiddler or Burp, you can search stuff. So if you search for E, Y, J, and 0, and hit enter, you can see a lot of tokens here actually. So you might think that when you are logging into Office, there's only like one token, but no, there's a lot of tokens to different services. And we're going to see later which services those are actually. But as you can see, there's a lot of tokens. Oh. Yes. Okay, so that was like a first kind of a small hands-on exercise. So which form of proof of identity did you use actually? So what was it? Username and password, right? So that's how cloud knew who you are. So you just type those username and password from that piece of paper, and now cloud knows who you are, or well, who you pretend to be. Okay, so let's move forward. And let's talk about bearer tokens, which you actually saw. And what are the bearer tokens? So according to standard, a bearer token is a thing that whoever has that can use that token to any purposes he or she wants to. So that's why the name is called bearer. So who has access to that token can use that token to any purposes in the service that is allowed. So you don't need to have that cryptographic material, also called as a proof of possession. So you only need to have that access token, or well, bearer token. And technically, it's just a string of something. So for client, that should be meaningless, that you don't know what it is, what it contains. It's just a string that client is sending to the service provider, like in this case, to Office-like services. And bearer tokens are predominant type of access tokens with OAuth 2. And well, as I told you, it's just an opaque string. It's not intended to have any meaning to the client. However, it could be also JSON Web Token or JWT, and this is actually what it usually is. And when it's a JSON Web Token, you can actually see what's inside that. And we will come back to that later. And as you saw from the previous step or the exercise, the way that you deliver this token to the service is the authorization header. Then there's a bearer, and then there's the string, whatever that is. And that can be that JSON Web Token. And some terminology regarding the OAuth. So we have this identity provider, but it's called authorization server in OAuth terminology. Also, the service provider is called a resource server. So it's a little bit different name, but same thing. And users are resource owners. And then the applications like Outlook or Teams, they are called clients or OAuth clients. And here's some process that how the authorization flow goes in OAuth. So first, you are a resource owner or user, and you want to access your data. So you are going to use the client. And then that client is going to connect to the authorization server and use the proof of identity you have chosen or you have agreed to, like using a password. And if everything is okay, meaning that the authorization server allows you to access services, it will create you a bearer token. And then the client will connect to that resource server and provide that bearer token. And now the service provider will then, give you the will provide you the service. So if you want to read your email, you pop up your Outlook client, you log in, and then you access the Excel Online, and it will return you your inbox and so on. So quite basic stuff, right? So then exercise. So when you did that, that you logged into that Office, so with authorization server you actually used. So those who are watching the stack trace, so or trace between your browser and the Office. So which authorization server did you use? Or do you know? No? Okay, so let's try to see if we can find any. So now if you type here, actually you don't need to type because it's right here. So here, so this login.microsoftonline.com, so that is the authorization server in this case. So that's Azure AD, where you send your credentials, for instance, and that's the correct one. And then did we see any resource servers? So basically all other here, which are not that authorization server, all those things that you have that token, they are resource servers. So if we quickly look at here, we can see that there's Graph API, then we have Web Shell, we have substrate.office.com, and I think that's the most used resource server here. Okay. And any questions at this point? No? Okay.
Why did you look for EYG?
Yeah, that's good question. So why did I look for EYG? Well, you're going to have answered that in next couple of slides. So yeah, good question. So because of this, so JSON Web Token or JWT. So let's talk about some technical stuff. Might be boring, might be not. We'll see. So what is a JSON Web Token? So that's just a compact way to present claims, and claims are related to that user or resource owner. So it says that who you are, for instance. It can tell you what device you are using, and that kind of information. So those are claims. And we have two implementations. So first one is JSON Web Signature, and that is usually used as a synonym to JWT, and that's wrong, but I can live with that. So JWT is not JWS, but it's both JWS and JWE. And I think you all have seen this JSON Web Signature kind of token, and that started with J. And then we have this other thing called JSON Web Encryption Token, and I think we might have time to get into that later on this day, but we'll see about that. But now let's talk about JWT. So it is used in Azure AD as an access token and ID token. So that's the standard for that. And it has 3 parts. So it has JOSI, or as I say, Jose. So JavaScript object sign-in encryption header, which is right here, the first part. And then that is base 64 encoded. And because that's JSON, it always starts with what is that, square bracket, and when you like base 64 encode that, it is going to be A, Y, and J. So that's why we search for that. Then we have a dot, and then we have the payload, which is usually the claim set as JSON, and then we have the signature part. So that's why it's called JSON Web Signature. So it's not encrypted, but it is signed with the key that is trusted by both parties. So I mean the authorization server and the resource server. So in this case, Azure AD signs that token, and then when you call, like for instance, Exchange Online APIs, Exchange Online trusts that signature. So that way they can be sure that you are who you claim you are, but that is not encrypted. So you can see what is inside that, and we're going to do that also in a minute. So there's a typical JOSI header. So we have the type here, JWT. We have the algorithm, which means the sign-in algorithm. And then we have the ID of the key. that you can use to verify the signature. So that's how it works. And here's a couple of things that you can have. So the signing algorithm, it can be RS256, which is quite typical. And then we have, it can be HMAC, SHA-256, or it can be none, which would be nice to hackers, because then you could create your own ones if that's not signed. And it still happens, trust me, but not with Azure AD anymore. So they always have to have that signature. Okay, and here's an example of the payload of that access token. So what there is typically, so we have the audience, which says which API you can use this to. Then there's an issuer, which means that which organization actually issued this token. And then we have, of course, the expiration date and time. Then we have the application ID. Who knows what is this application? Anybody? So that's Microsoft Office, for instance. And then we have the object ID, which is the user's object ID in Azure AD. And then we have scope. And scope can be like that you can call certain APIs only. Or if you have user impersonation, which is the best one, it means that you can do anything the user has permissions to do in that API. We have tenant ID, and then we have the user principal name. And this here, the audience, it's the resource server, again in the OAuth terminology. And then we have the issuer, which is authorization server. And then we have the scope, which usually is the API. So that's what's inside that access token. And then how to validate that signature. So it's based on standard, which means that you have the issuer here, and then /.well-known OpenID configuration. So issuer here is that one. So if you get an access token and you want to, verify this signature, you take this URL, and then you put it in front of this. And from there, you will get a list of things. And one of those are JWKS_URI. And that points to, in this case, in Azure AD, it points to this URL. And when you go there, you will get a list of keys in JSON format. Then you just need to pick the correct one, like that is matching the, sorry, wrong direction. That is matching the, where it is actually. Oh, yeah, sorry, here. In Josie header, there's a key ID. Then you just need to get the same key ID from here, and then you have the key material here, and then you can use that to verify the signature. So that's how it technically works. And also, this is an example from Azure AD, but other services who are using access token, that should also work in that way. So if you ever wonder that how Azure AD or the service is actually doing that, so this is the technical details, so how that is verified. Okay, so other uses for JWT in Azure AD, so it's not just for access tokens or ID tokens. You only have you can also use that to get PRT. Who knows what is PRT? I know Roberto does because he works for Microsoft. So that is a primary reference token, and it's stored in computers that are Azure AD joined. So it is used for proving identity of the device. And I'm going to demonstrate that at the end, if we have time. Also, you can use this to obtain PRDs, and then you can send some keys to Azure AD. So you use the same JWT format. So, but it's not the access token, but I'll show them to you at the end. Okay, well, yeah, primary reference token. So that is a long-lived token. So it's valid for 90 days, not 14 days as the documentation says. It's 90 days, and you can update that using the device certificates. And it is used technically in the background. It is used to get you new access tokens automatically. And these access tokens that you are gonna get using PRT, they have the device claim, which means that there's a device ID. And in Azure AD, those who don't know that, you can configure things called conditional access policies, and you can, for instance, say that, okay, you can log in if you have a device that is compliant, and that compliant information is stored in Azure AD in your device object. And now when you have access token that have that device ID, then Azure AD knows that you are using that device. So that's how this actually works. So yeah, what else did I have? I was supposed to mention about this. I think it might come to my mind at some point. Yes, there's a question.
By the sign-in frequency of the connection.
What was that?
Does the sign of the ART is that by the sign-in frequency of the conventional access? Sign-in frequency.
Sign-in frequency. Well, I don't know if I understood the question correctly, but that is valid for 90 days. That's pretty much.
The sign-in frequency, like it kind of sign you out after the time you put in the sign-in frequency.
No, this doesn't sign anybody out. So you only use this to get a new access token. Yeah, and it happens automatically. And yeah, the thing I was going to mention is that just a second. So if I go back a few slides.
Just a follow up on this question. Does it mean that if I get an end on this token, I can access the service forever? Because I can use this to refresh my session and so on. So what the purpose of 90 days?
Yeah, so the question was, yeah, so the question was that if you can get that token, can you log in like forever? Pretty much yes, but it's not easy to get because how would I put this? It's stored in your computer in a place that you can't access really. So it involves TPM, for instance, if you have, so you can't access that. But we have a ways to go around that, and we can even get our own ones. But anyways, the primary reference token is the most powerful one as a proof of identity, because you can, tell who you are and who also that what device you are using, but also that you can. Well, we will get back to that reference token stuff. But as a reference token, you can get access token to any client and any service, so there are no limits for that. But we will get back to that later, because that's the most interesting stuff. So where were we? Here. So now let's see what is inside the JWS, and we're going to use. Well, you can use whatever site you want to, but JWT.ms is okay, or then you can use the read AD in access token. But let's see. So now when I go back to developer tools here, I should be able to copy this. Where it is, headers, there. So just going to copy this like this, Control C. Then I can go to JWT.ms or any other tool you want to use, and I can then paste it here. And then you can see what we have, like what is the Josie header, and then what things we have here. So let's give a couple of minutes to you that you can actually see what's the contents. So then we can have a little discussion of this. And I can have a cup of water. And I'm also going to show you another way to do that with AAD internals. And loading the module takes long because Microsoft is checking that every time I load it. So what I'm doing here now is that I'm going to use one of the AAD internals methods or functions called read AAD in access token. And then when you provide the token, as you can see, it starts with AYJ0. And I hit enter. It does the same that the JWT. So it shows what claims there are. So let's talk about what we have here actually. So this token here, audience is graph.microsoft.com. So what that means, what service is this? Well, it's Microsoft Graph API. So you can use this token for that purpose. And it was issued by this tenant. So what is this tenant? Tenant ID. If you want to know that, you can go to aadinternals.com/OSINT. So here you can paste the tenant ID like this, and then it will tell you what tenant that was and some other information. So we can see that it's called T2.myoauth365.site, and we can see that there are a couple of domains there and so on and so on. But yeah, so using that tenant ID, you can see what's the organization actually who issued that. Then we have this time here. So
there's a report or somewhere that all those ID are linked to the tenants somewhere, or is it encrypted or encoded your ID?
Yeah, so the question is that is there a repository that tells you what is that, what the tenant ID means? No, there isn't. So this is the tool I created that can get you that information. So with tenant ID, you need to call a certain API, and then it returns you information about that tenant ID. But yeah, but there's no, well, there's a kind of repository, it's called Azure AD, but we can't access that directly. So yes. So this time here, so IAT, I can't remember what that what is that, but it's same as not before and not after or when that expires. And this time is it's what is that Linux time called? Anybody? I can't remember either. Yeah, but anyways, it's a Linux time, so it's seconds or milliseconds. Yeah, epoch, yes, epoch time, yes. So it's a milliseconds from 1st of January 1970. Yes, and then we have like AIO, I don't know what that means, but AMR, that's so interesting because it shows you that what kind of methods you use to sign in. So it can be PWD, which means password, or it can be MFA, or it can be RSA, and so on, but we will see that later. And then we see that what's the application ID, and it says that Office 365 shell WCSS client. I don't know what that is, but something that is used by the Office portal. Then we have ID type, which says it's user, and then we have IP address, and this is IP address of me, and probably you will have the same because we are using the same Wi-Fi network, okay? And what else interesting we have? Well, here's the scope that with this access token, you can only use email API from Graph API, and you have permissions to use files, read write, you OpenID profile, and then you have permissions to read write user information like my information. And you have the UPN here, and this WIDS means that, Robert, correct me if I tell something wrong, but I think this is a group memberships of that user. So what groups this user is member of. And then we have a tenant region scope, which means this is it doesn't mean not available, it means North America, because the tenant is in North America. So all this kind of information we also have the signature, but this particular service doesn't care about that, so it doesn't show it, and it doesn't even validate that. But with AAD internals, you can actually try to validate that. I don't know does it work because I haven't tried that in quite a long time. So if I provide validate, it should validate that is it okay, and it says that I can't verify that because there's a bug. So don't care about that. Okay, any questions about this? Yes.
So when you have the scope, user impersonation, and you want to access the Microsoft Graph API, can you print your own email just by having the user impersonation, or you need the panel read?
Yeah, there was a good question. So if the scope here is user impersonation, so can I read my email? Yes, you can if you have permission to do that in the backend. You can read others too if you have permissions in there, but user information just means that there are no limits what you can do like API wise. Yeah. But as far as I know, you can't get scope user underscore impersonation for Microsoft Graph API. Yeah. Because Microsoft want to make it more secure, and that's one way to do that, and it's actually a very good way. Okay, so then let's move forward, or is there any other questions? Yes?
Yes, that the service is calling the same data, the same token, same information, but the time will not be user.
Yes, so that's correct. So if you are using service principal to get like an access token, yeah, it's not user, but it doesn't always have the same claims. So the claims that depends on which service you are trying to access. So this is for Graph API. So it has like that ID type is user, but if that's service principal, it could be something else. But I don't know what it is in this case.
Same thing for many identity.
Yeah. Yeah. Okay, then a couple of words about the other type of JWT, which is JWE or JSON Web Encryption. So that is used in Azure AD to return keys and encrypted data from Azure AD. And you don't see that quite often. You see that when you are using the device that is joined and it's using that PRT to transfer data from Azure and back. And that's quite annoying if you want to, see what is going on between the device and Azure AD, because those access tokens are encrypted, so you can see them. So that's annoying, at least for me as a researcher. So, but there's a thing that we can do to access that, but it's a little bit different. So we have the same elements like shows a header. Then we have the encrypted key. Then we have the IV, and then we have the ciphertext, and finally authentication tag, which is just a piece of some text that is embedded to that ciphertext. So I don't know what's the usage for that, but it is there, like appendix, but you don't need it to anything. Okay, and how to encrypt that or decrypt? That's a very, very nice graph here. How you can do that. So I'll just leave it here so you can familiarize yourself with that later on. So we are not going to go like step by step with this. Yes, so exercise, but we actually can't do this yet because there hasn't been any JWTs yet, but there might be later on, so we'll see. So, yeah, so actually when I was studying this, how this works, we have the encryption algorithm that can be, well, there are a couple of options what it can be, and it can be like 8256 CBC or 8256 GBG or whatever that other one is. But regardless of what the algorithm says, Microsoft always use this one. So even though it says GCM, I think that's the correct one. So 8256 CGM, it still uses this one. So it was very annoying to me because I had everything in place. I tried to decrypt that, but it didn't work because I was trying to follow the standard and use that method that the algorithm claims it. So yeah, but I found out this by reverse engineering the a part of software that is encrypting this. So that's how I found that. But yeah, it was a bit annoying. I have another presentation for that, but that will take an hour, so we won't go deeper into that. So let's move forward to next thing, which is Azure AD authentication. Sorry, Azure AD token types. And we have 3 different types. So we have ID token, and the standard here is OpenID Connect. And the purpose is to identify the user. And that is valid for 1 hour after it's issued. The second one is access token, and that is OAuth 2 standard. And it is used for user identification, but also to authorization. So what is the difference between ID token and access token? Is that access token also contains information about what target you can access and also what you can do there, like that scope, for instance. So that you can access Graph API with this API scope. And then we have the refresh token, also OAuth 2. And that is used for requesting new access tokens when they are invalidated. And there is no limit for the lifetime for refresh token, but you need to use that in every 90 days. So that's valid for forever. So this make any sense? Yeah.
If you change your password or something, will it delete? Like, will you have to re-input the password to have a new token, or does it still go over?
Yeah, so if you reset your password, then that invalidates the refresh token, and then you need to use whatever new password you have. And you can also revoke that manually. If you're an admin, you can just go and revoke refresh token, then you need to give your username and password again. So yeah, good question. Any other questions? Oh, okay. So then the JWT type. So the standard we went through. So ID token, access token, they are JWS, and then the refresh token is JWE. But that is encrypted with the key only known to Microsoft, so we don't know what is inside that token actually. So we don't know, but we can see what is inside the access token, ID token. And can this be revoked? Well, access token you can't. So if you have access token and you reset your password, it doesn't matter. You can still use that access token as long as it's valid. So there might be a 1 hour gap. So even though you reset your password, you can still use that one. So you need to remember that. And same with ID token. Yeah, so it's valid. Yeah, even though you reset password, you can invalidate that. But however, there are new stuff in Azure AD that it's called, what is that called? Yeah, continuous access evaluation. So that kind of might help you on that. Okay, then about refresh tokens. So yeah, so refresh tokens are used to acquire new access tokens and ID tokens. And OAuth standard has some security guardrails. And the first one is that refresh token must be bound to the client it was issued. Well, yeah, so that doesn't work actually quite well with Azure AD. And it also must be bound to the scope and resource server consented by the resource owner, which means that when you log in, you will get the refresh token, and that is meant for certain service and for certain resource server. And if you use that refresh token to get an access token, you should only be able to do that for same scope and for same resource server. And that usually works like that. However, Azure AD implementation allows you to get those tokens for different scopes. So, which means that you, well, let's imagine that you have a refresh token for Outlook client for, let's say, a certain service endpoint. And then you use that refresh token. So you must use same client ID, of course, because that's Outlook client, but you can change the resource. So you can have an access token, the other tenant, for instance. So you can do that. So it doesn't work as the standard says. And then we have the FOCI, which is a totally different stuff, and we're going to get back to that later. So anybody heard about FOCI earlier? Okay, well, there's something new and interesting for you guys. Okay, so then a little bit longer exercise, which you can use to get access tokens using different methods. And here I'm using AD internals because you can choose what kind of things you are using. And when you get that access token and you dump that, you can see that there are different information now, for instance, for that what authentication methods you used. So I'm going to show examples here, and you can try that back at home and or at the same time if you want to. By the way, who of you have AD internals installed already? One, two, couple, yeah. So you can do this at the same time. So let's see. So the first one is was the ROPC, which was resource owner password credentials. So let's try that. Sorry about that. Just a second. Yeah. So if we now dump the access token, we can see that it used this password, and the client ID was a bit different. So it was 1B73 or something, and that's Azure Active Directory PowerShell. So that's what Azure AD internals is using to get that access token. And now let's do the same in interactive way. So I don't provide the credentials here using this method. I just leave it like this and hit enter. Now it opens a pop-up. So if you have MFA enabled, for instance, you can now use this and well, you'll see. So I'm going to do now MFA, hopefully. Yeah. And now when I dump the token, you can see that I use my own name here. And now when we go to AMR, we can see that I use password, but also MFA. So that information is stored in access token. So if you are trying to access service that that you are requiring MFA and you don't have it here, then you will be prompted that you need to log in again. But now, because we have that MFA claim, we can use this to services that require MFA, because it is the claim is here. And also we have some new information here, because this user has been synchronized from on-prem AD to Azure AD. We can see the on-prem SID, for instance. So you can match this user to the on-prem user you have in your on-prem AD. And you can also see that the scope is a little bit different. So I have a much more stuff here than in the previous one. Okay, and the next one is I use device code authentication flow. And it says that I should go to this address here, which I'm going to do now. Like this. And then I need to give this number or string. I give it here, and then it asks me to authenticate myself. So I can use that, which I already had. And that's it. So that's a one authentication method. So let's see how it looks now. So it shows only the same information, like I used password to log in. And that device code authentication flow is actually quite nice for phishing, because you can set the link to user that please authenticate or log in, and the user does that. User doesn't know what the user was doing. He or she just logs in, and you will get the access token. And now you can do whatever, same thing that the user can do. How to block that device code authentication flow? You can't.
Yeah. The only way to get the phishing, to get the phishing before you.
Yeah, that's the only way. Okay, so the next one is that we try to use refresh token to do that. And now let's see if we can get one. So actually, if I go to one of these requests to that login.maxonline.com, I should have it here. Let's try. So I'm just going to copy the whole response here and open my Notepad++. I need to prettify this, so I should have some plugins here. Format. And here we have refresh token. So when you actually log in to Azure AD, you will have 3 tokens. You have the access token, you have ID token, and refresh token. Well, this actually also depends on the service you are accessing, but in this case, we have the refresh token. So I'm just going to copy that. Okay. So I'm going to paste that, and then I need to provide client ID, which was somewhere here. like this, and then the scope was, or resource in this case. And it didn't work. Of course, it didn't work. So what was wrong? The grant is invalid, which means that it didn't like my refresh token for some reason. Don't know why. What was that? Yeah, that's what I thought that it might be. No, it doesn't want to do that. Well, that was nice demo, but it should work. But we don't, put any more time to this now. So the next kind of question here. No, let's go here. So why there are so many different methods to get access tokens? So is there anybody, any opinions or any guesses why? Yeah, so there are a lot of different kind of systems and different situations. For instance, that refresh token thing is because you need to renew them every now and then. And then that device code, it's meant for devices that don't have like display that you can use to log in, or not even a keyboard maybe. So that's the reason for that. Why it is turned on by default, I don't know, because usually you don't need to do that, but it is there anyways. And then you need to have that interactive flow so that you can provide MFA, because you can't do that in command line. So that's why there are so many different ones. And what token types was returned? So that was actually answered already here. So we got access token, refresh token, and ID token, and then also some client information in certain cases. But yeah. Okay, so then if there's any questions, we can move forward. Okay, so the next topic is that what is inside a refresh token? So that has been interested me a long time, but yeah, these kind of things there are, or technical background. So first of all, everything is encrypted using a public key. It's just a funny way to do that, but that's how it works, at least with Microsoft. And it's decrypted using a private key. And keys are only known to Microsoft, so you can't even get the public key anywhere. So this means that we don't know what is inside Azure AD refresh token, but we know what is inside ADFS refresh token. And ADFS is like federating services. And Azure AD is at least partly based on the same code base, not exactly, but anyways, at least partly. So let's try to see what is inside ADFS, because that's we know what we know. So here is the anatomy of the ADFS refresh token. So we have the token blob, which is here on green, and then we have the signature blob, which is in red. So token blob has certain information. So we have the token certificate. Well, we will get back to this later, but it has a lot of information. And then the signature, of course, it's a token signing private key, or you use the token signing private key to sign that refresh token. And here's the refresh token, or the token blob. Looks nice, right? And we know a couple of things here. So we know that here's a hash of that certificate you use to encrypt this. And we have some size information. And then we have the encrypted key. and IV blob here. And then the size of the encrypted token. And the last part of that token is the actual encrypted token. And the size depends, so it can be anything because it has claims also. So it's not always the same, but the header stuff is usually the same. Or well, it is always the same. So what is then inside that refresh token, the red one, when you encrypt this, or sorry, decrypt this? So we have claims. So pretty much same thing that you have with access tokens. So we can safely assume that this kind of information is also in Azure AD refresh token, although we cannot be sure. So what we have the client ID, we have the resource, and then we have the issuer, and then we have some more information about the actual user. I don't think that part is there because this is Windows related stuff. But if we look inside what is inside that single sign-on token, so we have this kind of information. So these are just pretty much stuff related to on-prem AD. So this is not in Azure AD, I assume, but this is in on-prem AD anyway. So we are going to just skip this one. But if you want to see what is inside AD refresh token, you can then come back to this. But anyways, it is safe to assume that at least this kind of information is included there. So when you use refresh token, Azure AD knows that what was the client ID, what was the resource, and also who was the issuer and who are you. So that information is probably stored in refresh token. Okay, then to FOCI. And this was actually quite interesting. So I found out this by accident. Then my colleague kind of made a little more research and published a paper about this. So FOCI stands for Family of Client IDs. And that is a group of Microsoft first-party applications. And there's a list in our GitHub. So I think there's roughly 36 or something. So we can actually see. So how many there are actually? So 33 at the moment. And this is what we know of. There might be others, but these are those clients. And they have a special refresh token called Family Refresh Token, or FRT. And that's not the refresh token for FOCI clients or FOCI access tokens. Now, the behavior is a little bit different. So you can use any FRT to get access token to any FOCI client and resource. So this is violating every guardrails of OAuth standard. So basically, this means that if you have refresh token for Teams client, you can get an access token for Outlook client, and so on. And this makes like that device code authentication flow quite powerful, because if you use that to get, well, for instance, Teams access token, you can exchange that to any other access token you want to, if they are sharing the same client, if they are FOCI clients. So this was like my phase when I learned that how that worked. Yes, so let's do a little bit exercise. And I try to do this actually using Fiddler. Let's see how it works. Again, Microsoft is checking the module. Okay, and there is. Yes, so first time when you use AD internals and you are trying to use the interactive, it needs to set some registry keys for it to work. So I need to restart that. Oh yeah, this is the server operating system. So I need to get this Internet Explorer enhanced security to off. Yeah, these are the joys of live demos. There we go. Okay, so now I got an access token for Teams. So let's see how that traffic looks like. The last part where you actually get the access tokens. So here is the last response, and you get an access token and refresh token, and then of course ID token. Now, this is the latest edition, and it was published like last week during the Black Hat Asia. So I kind of re-engineered the whole cache handling. So it now supports FOCI clients, which means that if you have a method or function that requires certain FOCI client, and you don't have that in cache, it can use the refresh token to get one. So let's see how it works. So I'm going to use run a function that gets some recon information as an insider from the Azure AD tenant, and it is using a different client ID, but it's a FOCI client it's trying to use, so it should work because we have that. And when we use that verbose, we can see what is actually happening there. Maybe too much information, but we can go to Fiddler. And what was the last thing? Yes, so this is where we are now. So I'm gonna just mark that as red. And now I'm trying to find out a correct place where we actually, or is that one? Yes. So here we are actually using refresh token of that Teams client because we have that and we can use that. So because FOCI works as it works, we don't need to care about anymore like do we have the correct access token to that certain service. So it's enough that we have one that is a FOCI or FRT actually, and we can use that to other clients however we want to. And now if we go further up here, in the beginning of this nice verbose stuff, we can see that it wanted to have an access token with this client ID to this resource, but it didn't find. But it says that, okay, this is a known FOCI client. So it's trying to get one using like that FOCI refresh token. Yes, so the question is that how can we recognize FOCI token? Does anybody have any idea? So if you are looking the trace and you zoom a bit, oh, let's see. It doesn't work actually. Why not? Okay. Yes, so whenever you are getting access token that is a FOCI, there's a FOCI equals 1. So now you know that that is a FOCI client. So it's quite easy actually to spot. But the actual access token doesn't have that information. So it's only when you are requesting that. So then that information is included, but otherwise, no. And by the way, if you are using AAD internals and you will get an access token that is a FOCI client that we don't know of, it will tell you that, hey, there's a new FOCI client, please report this to us so that we can add it into that list. So the FOCI stuff is just important for you to understand that how it works, because it can be used in bad purposes. And that's how it works. And by the way, when we ask from Microsoft, why is it this way? So do you know why? Yeah, so it's been used as a single sign-on solution for mobile phones. So that's why it is like this. But you don't need that anymore because you have PRTs, for instance. So, but it is still there. I don't know why. It might go away, maybe. Yeah. So some attack scenarios. So we have the phishing stuff. So you might have this man in the middle or adversary in the middle attacks, or you can use device code, or then you can steal the token. You can do the token theft. So you can steal token from a browser, or you can use a PRT. And I'm going to demonstrate these to you actually. And then you can also spoof the proof of identity. So if you can use so-called golden SAML attacks. So if you are able to create a SAML token, you can exchange that to access token. Also, if you have the thing called seamless single sign-on configured, you can use so-called silver tickets, Kerberos silver tickets, and you can exchange those to access tokens. And then if you have the device certificates, I mean, the computer that is joined to Azure AD, and if you can get your hands to that certificate, you can get your own PRT, and with that you can get again any access token you want. So do you want to see a demo about this?
Yes.
Some attack scenarios, okay. So let's do that then. So let's start with we need to prepare something first. So we have this Fiddler here. So what we're going to do is that we're going to join a device to Azure AD, and I'm going to show you that how you can monitor the traffic between that device and Azure AD all the time, even before it's joined, so that you can see what is happening. And for that purpose, we actually created a plugin that is available in GitHub, in SecureWorks GitHub. And we have a plugin for both Fiddler and also for Burp Suite. And the Burp one is a bit nicer because Fiddler is, well, it's a Fiddler. So it's not that nice, but I'm going to copy these, and they need to be copied where actually? Yes, so it's app data, local programs, Fiddler, and inspectors. So I'm going to paste those here, those DLLs. So now when we start Fiddler, it should have those in place. So let's see, I'm going to select something, change to inspectors, and now we have a new tab for PRT, and same here, and also the AT for access tokens, but we can't use those yet because we don't have any data for them. Okay, now I move to the Windows 10 box. I'm going to join to Azure AD, which is right here. And first thing first, so next thing is that I want to configure this computer to use that other server as a proxy so that we can see all the traffic. So there's a function for that in AAD internals. So it's called set AAD in proxy settings, and we're going to provide the proxy address. Need to copy that because can't remember. And it's port 888. And then I provide suites called Trust Fiddler. You can also use Trust Burp if you are using Burp Suite. But so this will set all the possible proxy settings I could find in Windows, and then it also trusts automatically the Fiddler root certificate, so it can actually block that. Okay. Wow. Yeah. Do you know why? I'm not an admin. Roberto, could you disable this checking of AAD internals every time I No? Yes, and now even when system is trying to use something, everything goes through my Fiddler now. So now let's try to join this to Azure AD. Or do we need to reboot this? Maybe I'll just reboot this first. And now just let's hope it's not going to install any updates, because then we're going to be here until 3 p.m. Okay, so we go to settings, we go to accounts, we go to access work or school, and then connect. But because we want to join, not register, we need to click here down here. So join this device already. So don't type here because that will register it, and that's a different thing. So we join. And are you sure about this? So yes, we are. And done. So now it's connected. And now we need to restart this again. So that we can then log in as that user. Now we change the select other user. Now, if we change to Fiddler, we can see that there's a lot of traffic going on in there. So we can see login.microsoftonline.com and so on and so on. And actually, you might want to filter things from Fiddler, so that you don't want to see everything like a JavaScript or whatever. You can just filter that out. So read that. Or any images, you don't need those either. Now, this could actually take a while when you first time using Fiddler or Burp, because you don't want to see everything. There are still some image files. Okay. So we are now logged in here. So let's try to see some stuff. Yes, so I tried to find a line with get key data. So let's see what we have inside here. So here we can see some token traffic going on. We can see refresh tokens, and then we can see a thing called session key JWT. And that is used to encrypt and decrypt stuff. So I'm going to show it to you how that works in a second. But before going there, so for instance here, what we see is that you are asking an access token, and what you get back is just a JSON blob. Let me get it to you. Let's put it in, okay. Like here, and now when I go search for a dot, going to replace that with dot and enter. So we can see that we asked for access token, and what we got back was actually JWE, so encrypted stuff. And if I open this one here, so we can see what's inside. So we can see that it is, well, it's lying to us that it is using GCM, it is using CBC. But anyways, we can see that this is a GAWE and the content of that is encrypted. So we can't see the access token. And that's because the device is using PRT to get that. So let's see if there's something that we can do about that. So I'll go to device now. And because this is a virtual server, a virtual computer, I don't have a TPM here, which means that I can actually export the keys of this device. So I can export the device, what is transportation key, but whatever. Well, we'll see. But I'll start the PowerShell here. As an admin, local admin to do this. Oh, let's try again. I like to use the ISE because I can zoom the font, so it's easier for you to read. So what I'm actually doing here, well, two things. So first of all, I can steal this device identity, but now I just want to get the key that I can decrypt the traffic. So I export the certificate like that. And then the transport key, which is the most important one. So now I'm just going to copy this and copy that to that server we are running Fiddler. So just going to put it here on the desktop. That's the good place for your keys, right? So I'm going to go to this get key data, and I'm going to switch to PRT. And now it is asking which transport key I want to use, and I am going to use the one that we stored in desktop, right? Like that. And then when I change to whatever request that has the session key, like here we go, well, I'll show you. So we have this session key JWE. So this is again that encrypted stuff. And now when I have the key, I can decrypt that. And this is what this tool automatically does. So it shows that, okay, I found this decrypted session key. So if you want to use that, just click the use, and I'm doing that. And now I can go to see these other requests that are encrypted. And I have that session key, I can now decrypt that. So for instance, I changed this one, and now without this, it would look like that JSON stuff, like here. So here's the encrypted stuff part, and now the tool can automatically decrypt that. So now we can see what access token you actually have here. And we can see that it's a FOCI again. we get refresh token, and we have access tokens, and so on. So this way, you can now start to learn what actually happens between the device and the Azure AD. So yeah, so that was the first demo related to that. But now, there's a question.
Sorry, how would you detect that kind of like session of use? Like Sentinel have anything or?
You can detect that because that's a legit way to do stuff. So you can detect that because from Azure AD point of view, it's just another normal request. So
Right.
yeah. So yeah. Okay. Then I will start another session of the PowerShell, and now I'm not an admin, I'm just a regular user. And I'm running this command now as a user, and because I'm logged in a computer that is Azure AD joined, I can get my, well, even though this would be using TPM, I couldn't get my hands to that PRT, but because how Windows works with Azure AD joined computers is that you can ask from Windows to give me PRT. So we can do that. So let's try. So I can just ask PRT token and it will give it to me because that's how Windows works. So I'm using the same method here than for instance, Outlook is using to get a new access token. So if you are able to compromise end user computer, you can just ask that PRT like this. And then you can use that to get access tokens. So here's an example. Like this. Well, actually, let's use PRT here. So that's more nice. And now when we dump this, we can see something interesting. So when we go to AMR, we can see that there's a password and RSA. So the RSA means that I use PRT to get that. And if I would have used MFA when I logged in or joined this computer to Azure AD, the MFA would be here too. So you would have an MFA claim. So this is an easy way to steal the token. So let's try this another way. So let's see, does it work? So I copied the PRT to clipboard and I'm going to use that from another computer now. And it seemed to work. So I just copied that and I was able to use that. So this is stealing tokens. This is fun stuff. We have still a bit of time. So I'll try to show you something I can't remember by heart, but let's see, we can do this together. So I have that key already. So I'm just going to copy also the certificate. to that server. Like here. So when you have the certificate and then you have that transferred key, you actually have just stolen the identity of that device. Which means that you can get your own PRTs using that as another user. Sounds weird, right? Let's see how this goes. Now I need to remember the commands I should use. Just a second. Yeah, that was. Yes, so what I did now is that I'm going to get a PRT key, so it has a certain cryptographic material, and I can do that because I have both the device certificate and then that transfer key, and I can get this to other users. So I use that Ostioma, but I'm going to use some other user. That's nice. Okay. So this is encrypted in Finnish, so it wants me to use MFA, but I'm configured this in a way that you can actually do that. So I can't show you the demo. But anyways, after getting those PRT keys, the access tokens that I would get with that PRT would have the device ID, but because I logged in as another user, it would be for another user. But anyways, if you're able to like steal the device identity, and this way to get access token, the Azure AD thinks that you are using that device, which you are not using. You only have that certificate and key. So you kind of stole the identity, and you can pretend to be that device. If that device is compliant, then all the access tokens you get with that PRT, Azure AD thinks that you are using compliant device, even that you are not. Yeah. Okay, so I showed you the device code stuff, the PRT, how you can use that to, if you are just a normal user, you can ask Windows to give me PRT because that's how it works. And then I showed you that how you can now, if you want to, you can see what is happening between the Azure AD joint device and the Azure AD with those keys. But that was all I got planned for today. So if you have any questions, you are free to ask. I'll be around here, so if you want to ask offline, that's also okay. Any questions now? No? Okay, thank you.
C'est parti. Anglais ou français? All right, so we're back. Thank you so much for attending this reverse engineering workshop in Go language. My name is Ivan Kwiatkowski, and I work for Kaspersky. I'm a reverse engineer / cybersecurity researcher, and the daily job that I do is I investigate APT cases and write reports on what we see and the types of attack that we have on out there. So in the course of my job, I end something you've never seen before. For me, I encountered Go long time, well, a few years ago now. It was something back then. Many people thought that Go was going to be the #1 language for malware in the future and so on. There were kind of good reasons to think it might become more popular. I think it might not have been the case, but still it's something we see occasionally from time to time. And so you can never rule out finding yourself in a situation where eventually you will have to reverse engineer something that has been written in Go language. And as such, it's kind of a good idea to at least have some general idea of how to approach such binaries. Now, usually when that turns out to be the case, when you encounter a new language, if you're familiar with reverse engineering C programs or C++ programs, you can kind of figure out where to go from there. Like, this experience usually translates pretty well to other languages. If you know of C reversing, then probably Delphi is not going to be too difficult. If you know C++ and Rust, most likely you'll be able to get into it. But Go tends to be sort of its own thing. And so I have noticed that among my peers, direct coworkers, and even further in the industry, a lot of people were sort of scared, might not be the correct word, but people were kind of reluctant to look into programs written in Go language. They would be like, okay, I have this new malware, it's written in Go, so maybe I will look at it next year when I have some time. So I just put it away and never have to look at it ever again. So, I mean, I understand this because having to look at Go, it really means having to acquire some sort of new skills. But at the same time, I promise you that Go turns out to be a language that I think is fairly easy to reverse engineer, and in fact, much more enjoyable than languages like C++, for instance, in my opinion. So, I mean, we will be able to talk about this in a little bit, but although the entry ticket is a little bit expensive when it comes to Go, because you have to learn new things that you might have not learned before or that you might not be aware of, as soon as you get this entry-level knowledge about the language and about the way that the compiler sorts out things inside binaries, then I think you'll probably do very fine. So let us talk a little bit about this workshop. What we're going to do is talk, first of all, about a bit of theory, and then it's going to be mostly practical tutorials. Usually when I work on a new language, I don't really like to look into the syntax or the specifics of it. And the reason for this is that, you know, there are so many languages out there. You really don't need /font to become an expert in all of them. And most of the time, as I mentioned earlier, then you really don't need to anyway. Like, if you get a program written in, I don't know, whatever new compiled language out there, odds are that if you just look at it in IDA, decompile it, and look at the assembly, if you know C or C++, you will be able to figure things out. And so you don't have to think about the way that, you don't have to learn the syntax of that programming language. You don't have to think about the programming concepts, because at the end of the day, there are always going to be traditional OOP or stuff like this. But I'm loath to admit that Go turns out to be sort of different enough from other languages that we won't really be able to escape this. So one of the first things that we will be doing in this tutorial is we will look at simple Go programs and we will study the generated code. This is actually a general methodology that I tend to use whenever I want to go into a new programming language or a new programming language reverse engineer, which is I just generate some hello worlds, modify them a little bit, and then figure out exactly how this source code translates into how it translates into a binary. So a little bit about Go, maybe. Why is that important? Well, we thought it would become more and more used by malware authors. I think it's somewhat true, also somewhat not true. 2 days ago, maybe 3 days ago now, I think there was an article from it was a Medium blog post. I don't recall exactly who wrote it, but it was about a Kimsuki malware, alpha something. I don't recall the name exactly, but this group actually developed a Go equivalent of their main malware family. Actually, I was really thinking of using this one for this tutorial, because it's something quite new, but unfortunately it's protected with the unprotected, so it's kind of not suitable for what we want to be doing there. But I mean, Go tends to show up here and there, but it's not really prevalent, or not as prevalent as we thought it would be initially. One of the reasons